Hey, Linux students, if you haven't gotten the drift yet that I think the AWK language is pretty useful, then perhaps our discussion today will convince you of its usefulness, especially in our study of log files and other computer generated information files that can be really tedious to scour through by hand. Awk scripting can lead the way to text parsing, pattern analysis, and report generation. So just to remind you, AWK is a scripting or programming language which allows the coder to easily analyze and manipulate structured data. The data like you see in a comma-separated values file or a pipe-separated data stream, or many of the other types of data output that you see on Linux systems and Windows systems alike. Why would you choose AWK over some other familiar language that you might know? Python comes to mind. Well, if you have been experimenting around with Python language or C language, you probably are finding out that coding and then debugging languages that are considered high-level languages can be a bit time-consuming, and syntax can sometimes be very persnickety, and you would like to just come up with a quick way to determine whether a text file has certain patterns in it, or you'd like to extract some data from a portion of the file. Well, here is AWK to the rescue. As we discussed previously, the language AWK is named after its creators. Each first letter for the last name, Aho, Weinberger, and Kernighan. And the scientists at AT&T Bell Laboratories were finding that they needed to analyze data and data streams as they went through AT&T switches and routers in telephony operations. So they developed the AWK language. In review, a AWK program has three basic compartments. It has begin actions. Those are the things that happen before your data input stream is processed line by line. So we might call this the setup portion of your script. Then there is the main body, which can consist of many sets of pattern action pairs. So for each line or record that is read into the program, the AWK program checks against the pattern, starting from the top and working down. And if a match is found, then the program performs the corresponding action. That happens all the way down through the body section. And then the third component of the script is the end set. And those things are done after the line-by-line processing completes. We might call this cleanup or tear down portion of our script. So let's look at one technique that you might find useful when you are putting together an awk script. So there are times when data files are created with a header row. That's usually a defining row. It has informational headings for each of the corresponding records that are in the file. And although that header row might be very useful in interpreting the subsequent data, it isn't data itself and is rarely used in the actual data processing part of the script. So we often want to strip that out before processing takes place. So you might be asking a question, how can you write an awk script that strips off that data header row? So we are going to our Linux machine, and in the next couple scripts we'll use two particular files that I've created. One is employee.txt, and the other is named English-French.txt. In fact, that's the file that I think I'm using today for both of my examples. Let's look at the top few rows of English-French. And you can see that there is a header row. It says English, French, gender. So if you have taken any French or Spanish for that matter, you'll know that in those languages, nouns have a gender of masculine or feminine, and that makes a big difference in proper grammatical use of that language. So here we have a file. Of course, it is not inclusive. It's just a short little subset of some of the nouns, and we have the English word in column 1 and the French word in column 2, and then the M or F designation in column 3. We see that there is row 1, a descriptive row, followed by data rows thereafter. We can look at also the tail end of the file and see that there is data down to the end. One thing that we want to accomplish is to strip off that header row, and then we might want to see how many data items are of the masculine form. I've changed into my bin directory, and I'm now going to see what kind of awk scripts that I have here to locate the one for stripping the header. So let's take a look at that. And then we can talk about what was done. Okay, short little script. Again, I have the shebang and the user bin awk, which happens to be the location of the awk preprocessor on this Linux Mint system. It's probably similar for you. You can use where is to find out where awk is installed on your system. The F indicates to the script that it will be accepting an input stream of data. Again, we want to look at, we have 3 blocks. You don't have to have all 3 blocks in any awk script. Any one of the 3 could be missing, or 2 of the 3 could be missing for that matter. But in our begin block, which are things that happen before the lines are processed, I'm going to set the field separator, remember that was a special variable, to colon, because the default is a space. So if we want the awk program to correctly recognize the colon as a field separator, we need to designate that. Then in the main body, I am going to do 2 things. I'm going to use another special variable called NR, or for the row number, or number of the row. And if that number of the row is exactly equal to 1, there is a special command next, which just says, hey, skip ahead. So that's all I want to do. If that row is 1, I know that's a header row. I want to bypass it. So this is just the easy way to do that. Since I only have 1 command, the colon is somewhat, or the semicolon is somewhat extraneous, but I guess it's a good habit to get into to end all your commands with the terminator, which is the semicolon. The second pattern command set, the pattern is if column 3 or field 3 is exactly equal to M, I want to print out the record and increment something called count. It's a variable I just made up, okay? And that's another convenient thing with awk, is there is no complicated variable declarations that need to be done. You just start using a name and it's there. And it starts out as null. Or if you start using it in a mathematical situation, then it started at 0. And in this particular case, I'm using the plus plus as the increment operator. So it will be incremented by 1 each time this particular command set is done. There is only 1 command in this program to be processed on the line by line processing. Then when that's done, as tear down or cleanup, we have the end condition. And at the end, I just want to print the text string, the number of masculine nouns are, and then the value in that count. So let's see how this operates. I may have run this before, so we'll see if it's in my history. And if it is not, we'll just cat that English-French file. And then we want to use the pipe and send that output. Oops. It would always help to spell the name of the script correctly. So here I've run that script, and we have the complete line print it out, and we can see that in every case, the gender column is an M, as what we would be expecting, and the last line tells us that the number of masculine nouns are 17. So this is the simple little script. I called it strip header.awk. Remember that you need to chmod plus X so that you add execute permissions to any script that you plan to run at the command line. And the item to note is the special use of the variable nr, checking that it is 1, and then using the awk command next to flip ahead to the next row. The second technique is a little more complicated. It involves using arrays. The awk language provides one-dimensional arrays so that you can store groups of related strings or numbers. Again, awk offers a lot of convenience to the scripter. It is not necessary to declare the size of an array before using it. Just say it, and there it is. So, very convenient. Now, arrays in awk are a bit different than in some languages that you may be familiar with. Awk arrays are what are called associative arrays. That means that each array is a collection of pairs. So the index is not necessarily a number. It could be a color, and the pair that goes with the color could maybe be the RGB color code that goes with that. So you don't count through awk arrays in the same way that you might be useful with, subscript 0, 1, 2, 3, 4, 5, on and on and on. You have mnemonic indexes. Now, we have the awk manual, and I'll make sure that a copy of this is on the learning management system, and there are many chapters, but I'll direct you to 10.1 Introduction to Arrays, where you can familiarize yourself with the way awk stores data. We can see in this particular example that we did have some numeric indexes and then values in the array, but more likely you would have a condition like the one below, where the array element is some number or some mnemonic word, and then its value is some pairing. So in this particular case, we're doing some English-French translation again, where we have the element dog, the value is chien, and cat, chat. Now the element 1 had the word 1 and the digit 1 both mapped to a value un, because we decided to translate the number 1 and the spelled out version both to the French translation. Okay. We can refer to an array element by its name and then a hard left bracket and a hard right bracket with an index enclosed within it. So let us look at this example. It happens to be the file masc-fem masculine feminine.awk, and let's first look at the 3 blocks in the processing and try to figure out what's going on, and then we'll run the script on the data to see the results. So again, we have a begin block where the field separator is set to the colon. Again, since we're using that same file with a header row, we're using the technique where the row number's 1, we're skipping ahead. This little tilde sign we can also reference back to the AWK manual and consider the Chapter 6 patterns, actions, and variables, and see that there are a variety of ways to do matching, pattern matching. When we use the double equal sign, that implies perfect match. So in this particular example, field 1 has to perfectly match the made-up word foo. And that may not be in existence in the file, so possibly nothing will print if that's the case. If we use the tilde and then the forward slashes with the pattern in it, this is what we call regular expression matching, and it's like regx in Linux, where we can have substrings and then also much more complicated patterns as well, like the caret symbol anchors something at the beginning of the line, $sign says it has to be at the end of the line, and all those other pattern matching combinations. So again, you can read Chapter 6 to refresh your mind on regular expressions. In this particular script, we're not doing anything out of the ordinary. We're just saying that field 3 has to have M in it. I also could have done the double equals M, since we know that particular field just has a single character, but I just wanted to show an alternative way. But here comes the new piece of information. If that field 3 on the given record does match the M, then I want to create, just by speaking it into existence, this array, this associative array called mask, and take the element defined by the second field and set it equal to the first field. Now, this can maybe start to get a bit confusing, so let us go back to that file and take a look at it. So what we are saying is create an array called MAC, and the index element will be the French word, and its pairing will be the English word. So masculine of chien equals dog, if we take this first line. If we take the second line, it would be masculine of chat equals cat. So we're not using, again, indexes that are 0, 1, 2, 3, 4. They're more like little file card placements where we just have two things that are associated together, connected together in this array. And we use the exact same thought or technique if the new record that comes in has that third element being F, then we're going to use a different array called fem and set its index of the French word equal to the English word. That is the body of our processing. For each record that comes in, that's all we're going to do is we're going to fill up one of these two arrays or neither of them, if that's the case. Then in the end, for our teardown or end processing, we are going to print out a little title. \n is a special code for a new line. And then we're going to print out the word masculine nouns, another new line, a bunch of dashes, and then step through. For X, and X isn't a variable, again, I just pulled out of a hat, and it just gets created by AWK, very convenient. So for X in mask, that means for each element cycling through all the elements in this array, for each one, print out the element name, dash, dash, and then its sister value from the array. And then we're going to do the same thing for the feminine nouns. For Y in fem, print Y and fem of Y. Let's watch it work. So we want to cat the, let's move back into the bin directory. And we're going to cat the English French text file, txt, and when we're going to pipe it to our mask fem.awk, and we will run it. And you will see that we have, I think, what is expected. We've got the masculine noun list with the French on the left, its English pairing on the right, all the way down till we've exhausted those, and then all the feminine nouns. All right. And then as a review, some of those commonly used special variables, you saw me use a couple of them, the FS for the field separator and the NR for the number of the current record. You can also change OFS if you would like an output field separator different from the default blank. and others as well, and a review of some of the commands that are available in AWK. It's actually very, very powerful. We have while loops, for loops, two kinds of for loops. We saw that we used a for variable in array. That was the construct that we used today. We can also use a for loop that is a 3-position loop similar to what you see in Python. We have while loops. We can break out of a loop, either while or for. We can do what we did in our both of the programs in order to skip ahead. We can use the next clause. And there are both simple prints and formatted prints for a more sophisticated looking output. So I hope that those few or couple examples will get you going and get you thinking on the kinds of things that you can do with AWK. It is really, I think, quite wonderful because you can just do so much so quickly. And again, the AWK manual will have just so many nice little examples. I encourage you to experiment. That is the way that you really make progress, is, sit down, do things, try things, see how they work, and have fun with it. So have fun with AWK.